You know, an expression is like half of an equation. It's just one part of the equation without the equal sign. So some expressions can be really simple, but our expressions in algebra start getting more and more complicated. So today we're just going to start to take a look at how complicated an expression can be and the different vocabulary terms we use with it. So if we take a look here, I have an expression. There is no equal sign with it. But we have something called terms in an expression. And terms are the parts of the expression that are separated by addition signs, subtraction signs, and division signs. Now notice, I did not say multiplication sign because multiplication does not separate terms in an expression. So here I have 5 times n. That would be a single term. But here I have my addition sign, so that's separating these two into two different terms. So my 1 would also be a term. This subtraction sign separates the next term. N would be a term. And this subtraction sign separates 8, which is another term. So addition, subtraction, and multiplication all separate terms, but not multiplication. Now, why is that important? Because in algebra, all terms that are alike we want to pull together. That helps us solve equations. Well, when I start to take a look at these terms, it's important that I see whether the terms are positive or negative. So when I see subtraction, my rule that I always follow is I change every subtraction sign to plus the opposite. That way I can see whether that term is a positive term or a negative term. So my first step when I see this, I need to rewrite this, changing every subtraction to plus, and whatever immediately follows that subtraction, I change to the opposite. So then I get 5n plus 1 plus opposite of n plus the opposite of 8. Now, what does that really look like? Well, my variables, my n's, look very different than my numbers, and I can show that using my algebra tiles. So if we take a look here, I have 5 positive n's. Therefore, I use the long bars and I use the black ones to represent a positive number. Now, my number itself is not a variable. So I use these little squares, but it's a positive, so I have a black little square. My negative n is a long, but it's red because it's negative. And my negative 8, that's just a number, it's an integer, so I use my red squares. Now when we look at it this way, we can see that the longs and these little squares don't look anything alike. And because they are not alike, we cannot pull them together. Now lots of kids are like, okay, I see it when it's like this, but I don't carry algebra tiles. Well, name your variables and your constants anything you want. You could say your variables are your cows and your constants are your chickens, and you can't ever pull your cows and chickens together. You've got to keep them separate. So when we take a look here, I can clearly see my terms. I have a 5n, which is positive, a 1, which is positive, a negative n, and a negative 8. My like terms are those things that I would pull together. So these 5n's look exactly like this negative n. So think of these as my cows. I would pull those together. That's a set of like terms. But I have a second set of like terms because I have this black square that looks just like the red squares. Now the colors are different just because one's positive and one's negative, but they're still the same things. These would be like my chickens, and I could pull those together. So like terms are things that look alike. Variables go with variables, numbers go with numbers. Now my coefficients only go with my variables. They tell me how many of those variables I have. Well, clearly I have 5 of the black n's, the long ones. That's one of my coefficients. It's 5. Notice I didn't put the n with it because the n is my variable. It has nothing to do with coefficients. Now I have a second coefficient because I have 1 of these reds. Now notice there's no 1 next to that n because we don't ever put the coefficient 1 with the variable. It's just assumed if we have 1 of them, we just write that variable. But if I'm going to identify my coefficients, I better identify that that negative 1 is there. Now my constants are just my numbers. They're constantly that number. They're anything that you see on the number line. So when I look at my number line, I can see a 1 and I can see a -8. Constants never have variables with them. Now when they say simplify, it simply means pull those like things that look alike together. Well, I need to pull my long blacks and my long reds together. But remember, when I pull this red and I put it with the black, it creates a 0 pair. It still creates a 0 pair when we're looking at our variables. It literally disappears. And when it disappears, what do I have left? Well, I have 4 blacks, and that's where I'm getting my 4n. That's simplifying. I'm pulling it together. Now, this black number can be pulled together with one of the red squares. They zero out because they're a 0 pair. So what do I have left? I have 7 red squares. So that's where I'm getting my plus -7. Now, why did I say plus? Because I can push these together, and that's what addition is. Now, this is just a formatting rule. We know in algebra we have our own language. We never write our final expression as plus a negative. Just like I can change minus to plus the opposite, I can go the reverse way. And this is just kind of the etiquette that we use. So if I have plus and negative, I'd always rewrite that, changing the plus to minus and taking the opposite of the negative and making it a positive. So in the end, my simplified expression, the expression where I pulled all those like things together, would be 4n minus 7. And that's kind of our job as we move on to equations. We always want to pull like things together. Now, the concept of simplifying, remember, we can add all the different ideas about distributive property. So we learned before that when we have distributive property, we always pause when we see those parentheses. So I look at this first problem, I see parentheses, I pause. And I look, does it have addition or subtraction on the inside? And it does. And I look, does it have a number on the outside that doesn't have any operation? And it does. The second I see that, I know I have to do my distributive property because that's my order of operation. So I have all addition here. I don't have to worry about changing minus to plus the opposite. So I have 3 groups of 2y plus 3 groups of 5y. Now remember, these are just telling me how many y's I have. I have 2 of those y's. I have 5 of those y's. Those are my coefficients. Well, when I do 3 groups of 2y, I just multiply my outside number times my 2 to get 6y. And I multiply 3 times 5 to get 15y. But notice, these look all the same. They're all y's. So I need to pull all those y's together because those are like terms. So 6y's plus 15y's gives me a total of 21y's. So that's that pulling of the like terms in action. Now, if you have subtraction, you have to change subtraction to plus the opposite. It helps us see our integers. So don't ever take any steps until you actually rewrite that expression. So I'm going to change that subtraction to plus, and that positive 7 goes to a negative 7. And that subtraction to plus, and that positive k goes to a negative k. Now that's already a plus. I don't have to do anything with it. Again, I see parentheses. I have to do my distributive property. So I have 5 groups of k plus negative 7. So I do 5 times k plus 5 times negative 7. And that's what's helping me see what my integers are. Now, this is outside that distributive property. It's not a part of that. So I'm just going to keep this as plus negative k plus 7. So now I can go ahead and start to look at my like terms. So 5 times k is 5k, and a positive times a negative is a negative. 5 times 7 is negative 35. And then I have a negative k and a positive 7. Okay, like terms. I've got some variables and I've got some constants, and I can only pull those like things together. So my k's can go with my k's, but I got to think about the colors. I have 5 black k's here, and I have 1 red k there. And I know that black and red is going to cancel each other out, so I'm left with 4 k's. Now that's completely different than my numbers. I have 35 red, or negative 35, and I have 7 black. Again, those 0 pairs are going to cancel out, but I have a lot more red than I do black. So I know I'm going to have a negative constant. So when I cancel those out, those zero pairs, I get negative 28. But remember, we never want to leave it as plus or negative. So I'm going to rewrite that, changing that plus to minus and taking the opposite of 28 to be positive 28. So we're kind of using all of this in action as we start to simplify these more complicated expressions. Now there's one that's really tricky, and I call it the floating subtraction sign. So I see these parentheses and I'm like, distributive property. And I look on the inside and I see a minus, so it's fitting the format. And I look on the outside and I'm like, oh, there's no number. Well, technically there really is a number there. What we just don't see is that number 1. Because we don't always have to write 1. So I always, when I have a floating subtraction sign, I add my 1 there. Now I see that subtraction, so I have to change it to plus the opposite of 1. Now I see a subtraction there, I change it plus to the opposite. So I always do that. Notice I never fail to do that. Well, here's my distributive property now. So I have a negative 1 times n, which is a negative n. And I have a negative 1 times negative 3, which is a positive 3. So when we go to pull our like terms together, I see my variables have to be pulled together. I have 8 blacks and 1 red, so we're going to have 1 zero pair cancel out. I'm left with 7 positives. And I have nothing to pull together with these numbers. And remember, I cannot put the number with the variable. It's not the same thing. So in the end, I just pull my number down. So our expressions are getting more complicated. We're building on what we've learned in the past. You need to look for that distributive property. You need to change your subtraction to plus the opposite. But if you work piece by piece and only pull together those things that truly look alike, variables with variables, constants with constants, you never pull those together, then that's simplifying your expressions. Good luck. I know you'll do well.